Welcome back, friends. Welcome to this lecture series where we are discussing some of the important topics for your GATE 2027 and further GATE examinations. So, we are continuing our important topics of highway engineering. Yes, we are continuing the important topics of highway engineering, and today we are going to see an important topic, that is traffic queue length calculations. That how we calculate the queue length. We'll understand the concept, and then we're going to understand the concept further by applying to some of the numericals. So let us start the class. Okay, it's a very short topic, so we'll understand queue length, how we find out the queue length. Okay, in the previous lectures also we have taken very important topics, so we'll continue that. So queue length, how to find out the queue length. And before going to topic, you can join this telegram group for further updates. Okay, so let us start queue length. So what is the queue length? So suppose there is a road. Okay, suppose there is a road. Suppose there is a road, and this road, there is a certain point, okay, certain point. And certain point, suppose there will be a arrival rate of the vehicles, right? There will be a rate of arrival of vehicles. That will be calling as what? The arrival rate. That will be calling as what? The arrival rate. That at what rate the vehicles are coming to this point. This arrival rate, suppose I am calling this as your V. So I am calling this as V vehicle per hour. Suppose this arrival rate I am calling as what? V vehicles per hour. That at this particular rate vehicles are coming. Suppose I am telling that 50 vehicles per hour or 200 vehicles per hour. What does that mean? That 200 vehicles are arriving at this point in 1 hour. Okay, so this is the arrival rate V. This is the arrival rate V. Then there will be a departure rate. Then there will be what? A departure rate. There will be what? A departure rate. Suppose the departure rate is S. Sometimes this departure rate is also known as saturation departure rate or simply saturation rate. Now, what is this saturation departure rate or departure rate, which is S vehicle per hour? This is the number of vehicles. This is the number of vehicles which are departing from this point, or actually the rate of departure of vehicles from this point. For example, suppose I am telling the arrival rate is 100 vehicles per hour. Means what? Every hour, if I am seeing to this point, 100 vehicles are arriving at this point. So this is the arrival rate. And suppose I am telling the departure rate is 80 vehicles per hour. That means what? From this point, 80 vehicles are departing per hour, right? So now from this arrival rate and departure rate, how we are going to find out? How we will find out the queue length? Okay, how we will find out the queue length? How we are going to find out this queue length? Okay, it's very easy. Now, what is queue length? We can find out queue length by using the formula, means the concept. First we understand the concept and then we go to the formula. Now, what is the concept? The concept is the queue length will be number of vehicles arrived. Okay, number of vehicles arrived minus number of vehicles departed. Number of vehicles arrived minus what? Number of vehicles departed. Okay, now you see from a particular point. Okay, from a particular point, because you see, if I am seeing queue length means what? That suppose here some number of vehicles are arriving, and then those those vehicles are departing also. Now, if the arrival rate is more and departure rate is less, then what will happen? More vehicles are arriving and less vehicles are departing. So what will happen? They will start forming a queue here or a line here. I can say a queue here or a line. Okay. So therefore, that is known as what? The queue. And the length of the queue. Length of the queue means what? Number of vehicles in queue. Number of vehicles in queue. Number of vehicles in queue. Queue length will be what? Very simple. Number of vehicles arrived minus number of vehicles departed. Yes, number of vehicles arrived minus number of vehicles departed. Okay, suppose I am telling that in 1 hour 100 vehicles arrived and I am telling that 80 vehicles departed. So those remaining 20 will be forming the queue. Yes, so I can say here queue length is equal to what? It is the number of vehicles in a queue. Okay, it is the number of vehicles. It is the number of vehicles in a queue. It is the number of vehicles in a queue. And as I told, the number of vehicles in the queue, and this is equal to what? The queue length is equal to what? Number of vehicles arrived minus number of vehicles departed. Now, how we are going to find out the number of vehicles arrived? The number of vehicles arrived will be equal to, very simple, it will be, suppose I am seeing the queue length at time t. At time t. At time t, I am seeing the queue length. Then what will be the number of vehicles arrived? The number of vehicles arrived is equal to what? Is equal to the arrival rate into time t. It is equal to what? The arrival rate into time t. And what is the number of vehicles departed? That is equal to the departure rate into time t. Yes, departure rate into time t. So this is the number of vehicles arrived in time t and this is the number of vehicles departed in time t. So if we subtract them, we'll get what? The queue length. Very easy. For example, if I am saying, let us see a very simple question. Let us see a very simple question. Suppose I am telling that the arrival rate is 200 vehicle per hour, suppose. The arrival rate is 200 vehicles per hour and the departure rate is suppose 150 vehicles per hour. The departure rate is 150 vehicles per hour. And if I am asking to find out the queue length, if I am asking to find out the queue length in t is equal to 30 minutes, okay, t is equal to 30 minutes, then what will be the queue length? Now see here, the 30 minutes, it is the time given in minutes, but if you see the rate, it is what? It is vehicle per hour. So I have to convert the minutes into hour. So this 30 minute will become how much? This 30 minutes will become, you see, half an hour, right? It is half hour. So if here I find out from this arrival rate, number of vehicles arrived, if I find out the number of vehicles arrived, okay, what the number of vehicles arrived? The arrival rate is 200. So 200 in half an hour. So it will be how many vehicles? It will be 100 vehicles have arrived in that half an hour or 30 minutes, right? That 100 vehicles have arrived. How I got? The arrival rate is 200 and then multiplied by the time is 0.5 hour or half hour. Yes. So I got the number of vehicles arrived. Now from here I can find out the number of vehicles departed. What will be the number of vehicles departed in that time? The departure rate is what? The departure rate is your 150 and the time is half an hour means 0.5 hour. This will give me what? This will give me 75 vehicles. So if I am finding the queue length, very easy. 100 vehicles arrived and then 75 vehicles departed. So this is equal to what? 25 are in the queue. So the queue length is 25. The queue length becomes what? Your 25. 100 minus 75. 100 is number of vehicles arrived and 75 is the number of vehicles departed. So simply we got what? Your 100 minus 75, that is equal 25 vehicles will be in the queue. So that is the queue length. Very easy. Let us solve another question. You see this question, what is written here? We have a 4-lane road. What is mentioned in the question? It's a 4-lane road or 4-lane highway has a normal traffic arrival rate of 900 vehicles per hour per lane. Okay, per hour per lane. Okay, so we have a 4-lane highway. Okay, we have a 4-lane highway. So number of lanes is 4, you see, and the arrival rate is what? The arrival rate is given 900 vehicles per hour per lane. It is per lane. If I want to find it for the whole highway, so arrival rate will be how much? Arrival rate will be equal to, you see, it is 900 vehicles per hour per lane and number of lanes is 4. So this will be equal to, you see, 3600 vehicle per hour. This is the arrival rate we got. This is the arrival rate we got. Okay. Now what is written? The normal capacity of each lane is 1200. This capacity is nothing but the departure rate. It is nothing but the departure rate. So indirectly what they have given is, this is the departure rate, or I can say this is the maximum departure rate they have given. They have given what? The maximum departure rate. Okay, this is the maximum departure rate. Now what else is given? An accident occurs. Okay, what is given? An accident occurs due to which your one lane is blocked for 30 minutes. And due to this rubber necking means what? Due to the accident, what happens? There is a road jam, that is rubber necking. Okay, the operating capacity of the remaining 3 open lanes reduces or drops by 20%. Means what? You see, here you see that we have 4 lanes. Okay, we have 4 lanes. We have these 4 lanes. Okay, now vehicles are arriving in this. Let me draw horizontally so that we can understand better. These are the 4 lanes. Okay, first lane, second lane, third lane and fourth lane. So 4 lanes are there, and you see from each lane what is the arrival rate? It is 900 vehicles per hour. So 900, 900, 900, 900. So total arrival rate is what? Your 3600 vehicle per hour. Okay, now under normal capacity, the maximum departure rate is how much? It is 1200 vehicle per hour per lane. But what is given? That one of the lane is blocked due to some accident. Okay, suppose we can just randomly choose any one. Suppose this is blocked due to accident. Now what happened? Now that in this, one second, give me some time. Interruption. Okay, so now here you see that when one lane is blocked, then other 3 lanes are operating. Obviously one lane is blocked but other 3 lanes are operating. But what is written? The operating capacity of the 3 open lanes drops by 20%. Drops by 20% means what? What is the capacity? It is 1200. The departure rate capacity is how much? It is 1200. But now it has dropped by 20%. Means what? It will become 0.8 times of 1200, right? Drop of 20% means what? Drop of 20% means it goes to 80%, right? Drop of 20% means what? It goes to 80%. So now the capacity is what? Now the operating capacity means the actual departure rate. Now this is the maximum departure rate under normal conditions, but this is not normal condition. This is what? An accident has happened due to which the capacity has reduced, and this is how much? This is 0.8 into 1200. So I can say this will be your 960 vehicle per hour per lane. Vehicle per hour per lane. Now we have 3 lanes only. Yes. So what will be the departure rate? The departure rate will be 3 into 960. So how much I will get? 960 into 3. I am getting 2880 vehicle per hour. So this is the departure rate and this becomes the arrival rate. I'll again explain the arrival rate and departure rate here. Okay, I'll again explain the arrival rate or departure rate here. Very simple. You see, first what happened, that the arrival rate is given 900 vehicles per hour per lane. So I can say here the arrival rate is how much? It is 900 vehicles per hour per lane. So see, departure will depend on, you see, try to understand, the departure will depend on what? The departure will depend on that how many lanes are open, but the arrival will not depend on the number of lanes open. They will anyhow be coming, right? Because see, here blockage is there, but before there is no blockage now. So what I can say, the vehicles will arrive in all the 4 lanes. Yes, the vehicles will arrive in all the 4 lanes. So I can say that the arrival rate will be how much? Because blockage is there, so now further there won't be any departure from this lane, but arrival will be there. If the road is blocked ahead, doesn't mean that vehicles will not arrive. They will not depart from that lane, but they will keep on arriving from that lane, right? They will keep on arriving from that lane. So I can say that here the arrival rate will be 900 into 4. Simply this is what? 900 into 4, because arrival will continue in all the 4 lanes. So 3600 vehicle per hour. That is the arrival rate. Now, what about the departure? Now, when we are discussing departure, what happened? The road was blocked in one lane. Due to some accident, this road is blocked in this one lane. So, when the road is blocked in this one lane, then what happened? When the road is blocked in this one lane, what happened? Now, vehicles will depart in the other 3 lanes. They will depart in the other 3 lanes. Now, it is given that the normal capacity or the normal departure rate is 1200. But due to this rubbernecking, means what? This blockage of one lane, the operating capacity of the remaining 3 open lanes drops by 20%. So under normal conditions, it would have been 1200. But now it drops by 20%, or I can say it drops to 80%. So 80% of 1200 will be 960 vehicle per hour per lane. And departure now can happen only in these 3 lanes. Arrival will occur in all the 4 lanes, but departure will occur in only 3 lanes because one lane is blocked. So I can say now the departure rate will be 960 into 3 lanes. Here you see it is very important, 3 lanes, because 3 lanes are operational. So you see, arrival will happen in all the 4 lanes, but departure will happen in only 3 lanes. So departure rate becomes how much? It becomes 2880 vehicles per hour. So now they're asking the maximum queue length accumulated per open lane. So when I'm finding the queue length, the blockage is happening for what? For 30 minutes. The blockage happened for 30 minutes. Yes, the blockage happened for 30 minutes. So you're trying to find out, 30 minutes means 0.5 hours. So you're trying to find out the queue length. So as I told, what will be the number of vehicles arrived in that 30 minutes? The number of vehicles arrived will be equal to your 3600. It will be equal to 3600 into 0.5, giving me why 0.5? Because half an hour. So this gives me what? 1800 vehicles have arrived. Okay, and then how many vehicles departed? So number of vehicles departed will be equal to what? See, the departure rate is what? 2880, and that will occur for 30 minutes because we are calculating at 30 minutes. So into 0.5, giving me how much? 1440 vehicles. So this many vehicles arrived and this many vehicles departed. Yes, this many vehicles departed. So can I find out the queue length now? What will be the queue length? The queue length will be equal to, you see, this is 1800 minus 1440, that is equal to, see, 360 vehicles. Yes, 360 vehicles. So the Q length will be how much? It is simply number of vehicles arrived minus number of vehicles departed. That becomes how much? 360 vehicles. Now these 360 vehicles will be queuing in the 3 lanes. Why? Because you see this lane is blocked, right? So vehicles will be arriving here in all the 4 lanes. But since this is blocked, they will move on to what? They will move on to the other lanes, right? So they will move on to the other lanes. Okay, so now the queuing will happen not in this lane. Why they will queue in this lane? Because it is blocked. So why they will queue in this lane? They will queue in the other 3 lanes. That is what is asked, the maximum queue length per open lane. So per open lane will be how much? There are 3 open lanes. So I can say this is the total queue length if you combine all the lanes. But if you are finding per lane, or I can say per open lane, so this is equal to how much? 360 divided by 3. So that is equal to 120 vehicles. So 120 vehicles per open lane. So very pretty simple theory. Okay. So let me just revise it for you, that if I am calculating the queue length, how I am going to calculate the queue length? How I am going to calculate the queue length? Just number of vehicles arrived minus number of vehicles departed. And how to find out the number of vehicles arrived? It is your arrival rate into time t, and this is departure rate into time t. Just in this question there was variation in the language of, what? Your I can say that the arrival rate and departure rate was given different language, and therefore we just got confused. But I explained to you how to find out the things, and from there we can find out the queue length. So this is a homework question for you. This question came in GATE 2026. Okay, this question came in GATE 2026. So it's a homework question for you. So read the question. Okay, read the question and solve the question and mention in the comment section the correct answer. Okay, read the question details of a long question. Okay, and the solution of this question I will provide in the Telegram group, and I'll also provide some more questions. Okay, I'll also provide some more questions. Okay, I'll also provide some more questions for solving. Okay, some more questions Telegram group, so you can join this Telegram group. Okay, where we'll be providing some more questions on Q length along with solutions. Okay, so more questions I'll provide in the Telegram group based on the simple concept. See, questions will be tricky, or questions might be, the language might be different. So we need to solve different kind of questions, but the concept remains same. The concept remains same. Concept is what? The concept is very simple. So I will revise this. Okay. So concept remains simple. Just the language you have to understand in different numericals, and therefore I'll provide you different questions in the group. So please join the group. I'll provide more questions, and I'll provide a PDF of Q length, questions and solutions. So you can see the question, you can try to solve the questions first, and then you can see the solution also. Okay. So again I will revise that this is the arrival rate, V vehicle per hour, and this is the departure rate, that is S vehicle per hour. So Q length is what? The number of vehicles in a queue. And how we'll find out the number of vehicles in a queue? That's the number of vehicles arrived minus number of vehicles departed. So this is simply V into T is the number of vehicles arrived, and this is what? Number of vehicles departed. That is S into T. Okay. So we need to find out the departure, arrival rate or departure rate, and then we can simply solve the question. So you see, first question was very simple. See here directly the arrival rate, departure rate is given, so it was very easy for us. So we found out number of vehicles arrived, the number of vehicles departed, we subtracted, we got the Q length, right? But they might change the language. Okay, they might change the language like this, but we understood, and the final concept is that only. Yes, the final concept is that number of vehicles arrived minus number of vehicles departed. Number of vehicles arrived is arrival rate into time, number of vehicles departed is your departure rate into time. Okay, so I explained this question, so there will be more type of question, but the core concept remains same, core formula remains same, just to understand the language of the question and to decode the question. So I'll provide the question in the group. You can solve that. Also, you can solve this question as the homework question. Okay, and the solution of this also I will provide in the group. So, and I will give some 5 questions, extra questions. You can solve them, and if you solve them along with solutions, that will be sufficient for you to finding out the Q length. Okay, thank you very much. So we studied today the Q length. We studied the arrival rate. You see, we studied what is the arrival rate. Okay, and then we studied the departure rate. Yes, we studied the departure rate or saturation rate or capacity rate. And then we understood that Q length is what? Q length is very simple. It is the number of vehicles arrived, which is V into T, arrival rate time, and then minus what? Number of vehicles departed into time. So number of vehicles arrived minus number of vehicles departed. Very simple. Okay. So thank you very much. So keep on seeing these lectures, and please comment the answers in the answer section, in the comment section, and also please join the Telegram group for more questions and more notes. I'll provide more notes and questions in the group. So please, not only for this topic, for other topics also I provide. So thank you very much. Thank you.